Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
And inspire you to do even greater things.
This is part 2 of a repeat episode of one of my previous conversations, first published in 2019. Since then, we have crossed 200 episodes and the listenership has also grown. Some of you have been asking how you can know more about the topics that were covered in the past. We felt that there could be related points shared by other guests in earlier episodes, but for new subscribers, it may not be easily discoverable. So, we thought that we would bring you select past episodes from time to time to help you discover more people and their stories. Also, over time, the format of the intro and the show notes have also changed, and this is an opportunity for us to refresh those as well. This conversation with Dorai Thodla is the second of 2 parts. The first part was published last week, and Dorai spoke about his serial entrepreneurship experience and how he innovatively finds problems to solve, etc. In this part, he continues to share his thoughts and experience on helping students learn to code by starting with coding, the joy of achievement when creating software that works. Also, how reuse and other software engineering concepts may be introduced gradually to build larger solutions. How a solution such as a bookstore can be used as an example to learn breaking the larger solution into smaller pieces that can be implemented incrementally. He also talks about the QUAC architecture, the KWAC architecture, essentially learning by watching someone as an apprentice, where the instructor also shares the thought process behind what is being done, leveraging learning patterns among students to learn in groups and each person guiding others. His experience from organizing hackathons and activating communities. And finally, how he finds and manages time to do so many things and where he derives his energy and inspiration from. I'm sure you will find this conversation inspiring. Listen on. You also have been working a lot with students, you said.
Yeah.
Right? And related to that, when you mentioned this build to learn, right?
Yeah.
Which is also probably twisting the whole thing, which is against the normal thing, saying you go somewhere, you learn to build or you learn to do something.
Yeah.
And then you also, I know you talk about thinking about thinking or learning to learn, those kinds of things. So when you kind of abstract or take some of these things to a higher level, how does that help you? Is this something that others can also use?
Yeah, I think it's like the learning to learn is meta learning, right? And thinking to think is meta thinking. So what happens is there is an actual problem. Students and computer science engineering student today learns about 3 to 4 programming languages. Especially if you're at Nana University, everybody starts out with C. Then they learn C++, and then they learn one of the things like either Java or C# or any of these things. They're all fairly related languages, so it's incrementally they get to more complex kind of things. But if you look at the system has a lot of theory and maybe like a couple of hours of practicals, maybe 2 practical sessions in a week, 2 hours. And they're given a list of problems and they're supposed to find the solutions. And students apply the same technique they apply to their theoretical study. They're saying, okay, I'll mug up all these 20 programs. And if anything comes, I'm just going to just, reproduce it. The funny thing is that that is encouraged. In fact, I've heard cases where the teachers will look at your program before you enter it into the computer. And then even if one variable has a different name, they will say, hey, no, you can't enter the program because it's wrong. Wow. They say, no, but this is like a different algorithm. And I have one really frustrated user. Now I think he used to work for Wikimedia Foundation. Now I think he works in Berkeley on Jupyter. He used to tell me that, hey, most of those programs are fairly dumb and I could actually reduce it to half their size and write it, but I was never allowed to input them because there is no way for the teacher to verify. And that's sad. And so what happens is about 70 to 80% of the students come out thinking that programming is another mugging job. And I say programming is very hard because I need to mug up 20 programs to get answers. And this is, I think, uniquely Indian in some sense. May not be true in some of the better institutions, but it's true in most of the institutions. So one thing that we noticed was that people were scared of doing their final year projects. So some of them used to just go buy it. Not all of them, but some of them. And I used to ask these guys, why do you buy it? Because they said, I don't know how to write this big program. And they give me some IEEE paper. I'm supposed to read it, and then I'm produced this project. And I have no idea how to go from reading a vague spec to a concrete implementation that works. And I'm scared of failing in this test. And so it's a very legitimate reason. So we said, okay, let's start doing these simple sessions. Like we started these programming clubs. And the programming clubs is where everybody comes and nobody knows anything, and everybody writes some programs and people help each other and then get it to work. You won't, I don't know whether you experienced this before, is that one of the biggest joys in creating something is to see it work first time. And then, hello world programs are easy to write now because in Python it's just one line. But even if you write a simple Fibonacci series or draw a small house using turtle graphics or any of those kinds of things, and the first time you see it working, you say, wow, that's pretty cool. All I did was type in some 5 to 10 lines of code, and then here it is producing a beautiful graphic. So first you need to introduce them to the joy of programming, joy of creating things. It doesn't matter what they create. And then slowly increase the complexity of what they're building. And the way to increase complexity is show them how to reuse the stuff that they have already done. These are all good software principles anyway. So I introduce functions when I'm teaching programming in the second session itself. Because, say draw a square using a turtle graphics and then turn square into a function, then start reusing the square and then draw squares of different sizes, parameterize the length of the side and that kind of stuff. And so they start getting a complex thing. Oh, it's not that complex. Once I write something and I can package it in some certain way that I can reuse it, then I can use it as a building block for building something else. And that is not taught in classes. Right? Because they don't have that much of time, covering the syntax. When they say cover the syllabus, they have to cover the entire syntax of Java. You need to get them, work on 20 programs and that kind of stuff. So we started with that. And then we said, okay, this is fine. And then I noticed one problem. And I said, when I told somebody, hey, go build a simple program to, for a bookstore business. And then they said, what is bookstore business? And said, okay, imagine there is a list of books. Somebody comes and searches for a book and they should be able to find a book and find out which shelf it is on. That simple. And somebody enters all this information about book titles and authors and shelves where the books are there. That requires a basic, simple database design. One table, a simple ability to take this search and then apply it, generate like 3 different types of searches, one for author, one for book title, one for partial book title. You have to, when you start thinking about it and they start implementing it in small bits, then we realize that, oh, okay, then I need a user interface. How does the user enter the query? And I need another user interface for entering new books. Should I upload them using, a CSV file or an Excel file kind of thing? And so incrementally they start realizing the problems that they need to solve to implement such a simple application. And we realized that none of them knew that when you gave a problem at that level, which most of the industry people think, wow, that's a simple problem. It's that, search a list of items and show the results. And seems like a simple problem, but when you give that problem, students do not know how to take that problem and end up with this bunch of functions that actually perform. So notice that, hey, there is a gap here. And even though they are taught UML diagram, software engineering and all that sort of stuff, it's too abstract for them. So we want to make it concrete. And that is what these sessions are about. And this cannot be done in like half an hour's time or 15 hours, 45 minutes, which is with their class, or 2 hours, which is in a lab. We said, hey, come here, sit, and there will be somebody experienced who can help you if you want. But try it yourself and pick a problem, small problem to solve. No problem is small enough. But it should show something in the end. You should be able to demonstrate something in the end. So they learn a little bit about the user interface. They'll learn a little bit about the underlying database design. They know a little bit, in this case, if they're building a web application, the front end and the back end of the web, and what is a REST API. All these little things come, but if you take all these topics that they learn by doing and make a list and teach them in the class, they'll be bored out of their mind. Programming is like, cricket. You can read a lot about cricket, watch a lot of cricket matches, but unless you take a bat and get into the field, you won't know how to hit a ball, or unless you take a ball and throw it, you don't know how to actually bowl, right? And it's a practice-based discipline. And then theory is good, and knowing algorithms is great, but knowing how to use the algorithm and why to use them is equally important. And that's essentially what we are trying to do with Build to Learn.
Wow, wonderful. Yeah, that actually answers a question that I wanted to ask, but anyway, I will still go ahead. What qualities do you think students need? Everyone talks about this gap between academia and when they get into the industry or actually working. You touched upon a lot of things in terms of the curriculum or how some of these topics are treated. But as an individual, an aspiring student, first of all, goes through all this in academia, is prepared to, or rather he's prepped up to be an individual contributor, and then probably better than the others and so on. So from that to more of a team sport, even if it is just one more person that you're working with, what have you found, and what would be some tips that you would give them?
So I think individual contribution initially is good, because what happens is, otherwise, if you are not a very persevering person, that is, it's easy to turn around somebody and ask them a question. And normally it tends to be teachers, teaching assistants, or lab in charge, or whoever. And then initially you need to struggle a little bit. What I do when I teach is I tell them right up front that I'm terrible in typing. I'm going to make lots of mistakes when I'm typing code, and I always type code in front of them. I don't copy paste or anything like that. And then see the thinking process. As you're typing the code, you keep explaining, okay, this is what I'm thinking, and then I make a mistake. And then suddenly I look around and said, hey, there is a mistake. And even before I ask for help, 3 students will say, sir, you missed that semicolon there, or sir, you named this variable wrong here. They're watching, they're observing, and they're doing this kind of. Doug Engelbart had this, he's the person who invented the mouse and co-invented hypertext, and he did some amazing things in his life. And had the chance of meeting him and working with him for a couple of years, he had this term called QWAC, KWAC, and we used to joke about it. It's called Knowledge Workshop Architect. And essentially what he says is that you can learn more about an editor like Emacs or VI by watching somebody edit than a practitioner. So you need this, it's kind of apprentice style programming, right? Where you sit with somebody who's very good, and then they start doing it and said, how did you do that? How did you do that? And this is what I think part of pair programming success is, is that you need to be exposed to doing things that you've never done before, because you don't even know what to look for. So these Build to Learn sessions will make that happen. But going back to your question, I think there are several things, right? Give them really small problems, but don't wait till the final year when they have to do the project. So what we started doing was what are called mini projects in the 3rd year. In this college, it's called KCG College of Technology. We started doing micro projects in the 2nd year. Now, I think at the end of 1st year itself, we are going to ask them to start doing some things. So thanks to technology development, now I think there are these Lambda functions. The Lambda serverless computing, and all these things are becoming popular, right? What people can do is write really tiny functions, and then initially show them. Just give them a spec on writing a ton of these functions. Then asking them to thread these functions together to build little nano products, or Udacity is a nano degree program, right? So it's like something like that. And then build micro products out of it, and then take these micro products and give it to people to test it. So when you get to a level of complexity where a single person cannot understand the whole program, you have a small team working on it, and then you divide the work. And maybe somebody does the front end because they're very good in design. somebody does the back end. The front end is all now JavaScript and React and Angular, Vue.js and all those kinds of things. And the back end could be your favorite programming language. Used to be PHP before, Python now, Ruby, Java, of course, and any of those kinds of things. And then some database, many of these good programming languages also have, object to relational mapper kind of thing, but initially they have to directly write database statements themselves. And so this is and then rotate them, move the backend guy to the front end guy to the database, that kind of stuff, so that you can build a full stack programmer. But the interesting thing is not full stack. They need to understand from the time they type one character in the keyboard to the time they see one character back on their screen, what really goes on. What happens when you type this character? Who's handling this? Where is it going in? What is going over the internet? What is the server receiving? What happens on the server? What does the web server do? What does the application server or the application attached to the web server do? How does it access the database? How does it get information back? The entire round trip, they have to know that. Then once you start understanding this, and do it with the smallest, the simplest program possible. So we actually ask them to do a simple to-do list, the simplest possible ones. Add an item, delete an item, change an item. To-do list consists of just one field and maybe a priority. And then we introduce add priority. Now you sort it by priority. Then add date, due date. Now you sort it by due date. So you can take the small thing, smallest possible thing, teach them how to do it, demystify the whole thing, show them what happens at each one of the stages. And that will give them a lot of confidence. See, out in every engineering institution I've seen, there are normally a few really big stars. There are very few, 3 to 5 people, sometimes maybe only one in each batch, but sometimes 3 to 5 people. And these are all the kind of people that Googles and the Facebooks and the LinkedIns of the world, Microsofts will hire. And how do they get to where they got? Because they were very interested in programming when they were in school, and they never lost that interest when they came to college. And they've been hacking and building things from their first year. And I normally identify the first years who are enthusiastic about programming are the ones that I pick into all these programming clubs. And a few of them inspire a lot of others. In fact, some of the people that I work with, at least I can give you 2 or 3 cases where they not only learned a lot of things on their own, but they also taught a whole bunch of people. Because they want company. Yeah, like this guy by name UV, I mentioned 2009 when I walked into KCG, and he was one of the programmers. And I know we used to chat about this, and he used to be frustrated. He used to bring home his friends and teach them JavaScript and wanted them to build something, and used to be frustrated when they didn't do it, kind of thing. And I have now an intern by name Ashish who does exactly the same thing. He's teaching, he was saying, I'll produce 4 people for you to take as interns because they'll pass, I'll make them pass this, this tough test we normally give to interns, and without showing them what the problems are, and I'll bring their skills up to that level. So the good ones, once they get confident, have this urge to share that, and it happens a lot among students. They do combined studies, and the good ones are really, really good. So if you can seed them, and then if you can and students can teach other students better than teachers can teach students, and not because teachers are not good, it's just that teachers are at a different level of understanding. Whereas students know exactly what other students' problems are. And even the ones who have gone past all the initial stumbling blocks and have become experts, they can relate to the problems of the students. And students are fairly frank about telling others, hey, tell me what it is, and I don't understand this thing. And they're not shy to ask for help. So I think putting groups of students together, doing a lot of little projects, I would put a weekly hackathon, in place, 4 hours. Sit there and just build something. Don't worry about the output. Don't judge it. The fact that you can sit for 4 hours and code and test itself is a skill that you need to build.
Are there any plans to take this beyond? I'm assuming it is all running in Chennai now.
Yeah, right now it's running in Chennai. I've had some requests from Bangalore to do it. we tried a couple of variations. We just did our first hackathon. It's actually MLH. It's a GitHub sponsored hackathon. I think happened in several hundred locations, and we did in Chennai. There are variations of this that we are trying to do. So our theme is basically build to learn, learn to build, right? Then a couple of cheesy things like learn to learn and learn to earn and those kinds of things, right? You can play around with words, but essentially we want them to move from building to learn, and then learning how to build, and then how to take things that they build and then start getting these small projects and stuff like that. We're trying to figure out whether we can do it, scale it by using online, like coding competition style approach. We're looking at that because physically there are about 3-4 of us as volunteers, and I think the volunteer group is growing a little bit, but traveling, many of them are students and a couple of them are working, and traveling around and doing it is difficult. So we want to bootstrap it in a few places, but what we decided finally is to do themed versions of Build to Learn. So we'll do one Build to Learn session will be Android, and where they'll be initially taught how to build an Android application. Then everybody will pick one application to do, and then they'll build it over a period of time. And it's a very what is called not instructor driven, but very lead driven approach, where project lead or a team lead or a tech lead will guide them, guide 3-4 teams kind of stuff. And once we work out the mechanics and then we are happy with how we are doing it, then we try to set up a Slack group to see whether we can get it done online, but somehow it doesn't seem to work very well. So we need to crack that part, and so we are introducing them more and more to online competition. So we're going to go from offline competitions to online competitions this year. 2019, that's every month we'll do one mini hackathon, and we'll probably do it in a couple of colleges, but we'll also do it independent of all colleges, so that anybody from any college can come and join this kind of thing. And the mentors are all people who are working, because there are a lot of startups looking for interns, and the biggest problem is they can't find an intern where they can point them to something and they go and build it, right? They need to guide them and spend a lot of time with them. So they would like some higher maturity level of interns, but if they know that they built like 3-4 little tiny products, and even if 70% of the code is copied from some GitHub repo or some other project, open source project, that's fine. If they know how to do some version management, how to do some unit testing, and some basic core skills, if they learn, I think a lot of startups will be interested in giving small projects on a freelance basis, or have these remote interns or virtual interns who can work online. And when you get it to that level and we're comfortable with the process a little bit, then we may want to scale it. But we want to do all the experiments where we can physically see people initially. And the first year was spent just running these Build to Learn events, and as I mentioned, sometimes it was 20 people, sometimes it was 80 people. Once I think it was like almost 120, and we had to show them off because we didn't have enough space. But we are going to try different experiments. We're going to change the metrics on not how many people come to these events, but how many products or micro products are built in a year, and that is going to be our focus. And sometime by the middle of the year, or maybe within after 3 to 4 months, we may start experimenting with some other locations.
Oh, wonderful. As always, Dorai, it's very, very energizing to talk to you right from the time. I think we met first in 95, I think, when you were describing the business application builder. I still remember the first meeting that we had. I'm very amazed in terms of how you keep abreast of technology, not only knowing about the keywords, but actually applying them where they fit in and putting them to use, that is converting your ideas into action. And of course, the energy, it's very contagious, I would say. Those of you who met you will definitely know that, and I can definitely vouch for it. I keep telling a lot of people that Dorai has been my inspiration for a lot of things, now, particularly, keeping in touch with what's happening, and then coming up with alternatives, coming up with ideas and all that. I don't know how you manage time with all this, I'm really thankful that you were able to spare some time for this. I think there are a lot more questions. We might probably need to do one more session, but I don't want to make this too long so that people who listen can take away a lot of things from here and then start applying them.
Yeah, thank you very much. See, I think it's easy to get excited about certain things, right? And you've always been excited about certain aspects, like quality, for example. And I still remember first meeting. I think I came to the TUL. Gopal organized it, and I came and gave the first talk. I think to a bunch of people.
Yeah,
this is even before you joined, Integra.
Right.
And then we had so many interactions after that. And I think finding time, if it is important, is it's not a big problem, right? If you're doing things that you like doing, you have the whole day open. And like I'm at a stage where I have grandchildren, and like other than my wife, there is nobody else who's going to demand a lot of my time. And she has been very reasonable right from the day we got married. So she lets me do lots of things, in whatever way I want. And so I do have a lot of time. And then I love technology. And then working with young students, it generates. I tell you, they're amazing. Whether they know things or not, whether they have a problem or not, the current generation is extremely inspiring because they are some of the most innovative and socially conscious generation that I have seen. I mean, I keep looking at some of them and keep asking myself, what was I doing at this age? And I think I was just mostly reading science fiction books and chatting with my friends. And here there are people who are doing some really amazing things. So I draw my inspiration from working with young minds. And then startups, that is the other community where people go far beyond their calling, in terms of, the effort they put in and all that, and how they work, and they're smart, and they're always facing problems. They know how to solve problems, and they're like eternally optimistic. And so it's the couple of communities where, there is nothing but energy and optimism. And you have to be lucky to be, among all these people. And that is the part I cherish the most. And of course, spending time, if you are really interested in doing what you're doing, then is not a big issue because you can always find time.
Thanks, Dorai, once again. Thank you.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.